All right, let's talk about one of the biggest questions in AI security today. How can you actually trust an AI that's making decisions on your behalf? Look, it's not enough for an AI to just get the right answer. You have to know how confident it is in that answer. Without that, you're just flying blind. So let's get into it.
I mean, really think about this for a second. We're starting to rely on AI for some really critical stuff. But what happens when it gives you a completely terrible answer, but it does it with absolute, unshakable certainty? This isn't some far-off sci-fi problem. It's a real-world challenge for anyone trying to deploy AI safely right now.
And you can see here, this is really two sides of the same very dangerous coin. On one side, you've got a high-confidence, wrong answer. The AI is so sure of itself that it greenlights a fraudulent payment, and because it's so confident, users just trust the hallucination. But on the other side, you've got a low-confidence, critical answer. The AI just isn't sure enough about a genuine security threat, so the whole thing gets missed. Either way, it's a massive failure of trust.
So how do we stop this from happening? Well, the key is learning how to decode the model's confidence. And let me tell you, this isn't just some nice-to-have metric. It's an absolutely fundamental security control.
You know, at its heart, the idea of a response confidence level is actually pretty simple. It's just a score, usually between 0 and 1, that tells you how likely the AI thinks its own answer is correct. So a score of, say, 0.9 suggests it's about 90% sure. But a 0.2? Yeah, that means it's pretty much just taking a wild guess. So why is this so important? Because this isn't just some data science jargon. It's an incredibly powerful security tool. You can use it to automatically route those really risky decisions to a human for a second look. If an incident happens, you can go back and see exactly how confident the AI was at that moment. And for regulators, this gives you concrete, auditable evidence that your AI isn't just making high-stakes decisions blindly. Okay, so we've got this raw signal, but how do we actually turn it into a reliable control? Let's look at how to make this confidence score truly usable and, safe.
And this right here is absolutely crucial. You can't just take the raw confidence score straight from the model and trust it. A model can be systemically overconfident, like that know-it-all friend we all have, or it can be underconfident. To make this score actually mean something, to make it reflect reality, you have to calibrate it.
And look, this quote from the source material just hits the nail on the head. If you don't calibrate, you can't trust the signal. Simple as that. And if you can't trust the signal, any safety guardrails or access controls you build on top of it are basically built on a foundation of sand. Calibration is what makes sure that when the model says it's 90% confident, it's actually right about 90% of the time.
Okay, so we get the why. Now it's time for the how. Let's actually walk through the playbook for implementing this in a real, secure AI system.
It really breaks down into 4 key steps. First, you've got to design the signal itself, figure out how to compute that raw score. Second, and this is the big one, you calibrate it and then you set different thresholds for different levels of risk. Third, you log everything. And finally, you take that calibrated, logged signal and you integrate it directly into your automated safety guardrails.
And what's so cool about this is how it makes the idea of risk-based security really tangible. I mean, not all AI tasks are created equal, right? For a super high-risk action, like a financial transaction, low confidence should probably trigger a hard block, or at the very least, a mandatory human review. But for something low risk, like, generating some marketing copy, you can probably let that proceed with much lighter guardrails. The risk level dictates the action.
Now, to make any of this work, you have to have rock-solid logging. And it's not just about the final answer. You need to know who made the request, which model was used, the prompt, the response, and crucially, right there at the bottom, you need that response confidence score. This log becomes your single source of truth for monitoring, for investigations, and for audits.
And once you have all that amazing, detailed logging, you can set up 2 really critical security alerts. The first one is kind of the obvious one. Flag any high-impact action that was taken with low confidence. That's a clear policy violation. But the second one, it's a little sneakier. You want an alert for when confidence suddenly spikes for no good reason. That could just be a miscalibration, or it could be a sign of an adversarial attack designed to fool your system.
So, who actually does all this work? A really common mistake is thinking this is just a problem for the data scientists to solve. But making AI secure and trustworthy, that is truly a team sport.
Of course, it all starts with the data science team. They're the ones who figure out how to compute the confidence for each model, and, critically, they own that whole calibration process.
Next up, security engineering steps in. They're the ones who take the business risk and translate it into actual technical policy by defining the exact confidence thresholds for those sensitive actions.
But they're not just making this up in a vacuum. The product owners are the ones who decide the business risk policies in the first place. They have to determine what level of risk is acceptable for their product and when a human absolutely needs to be in the loop.
Then, to make sure everything is documented and defensible, your governance, risk, and compliance team comes in. They map all of these technical controls back to formal frameworks, like the one from NIST.
And finally, who's on the front lines? That's your Security Operations Center, or SOC. They're the ones watching the alerts, and they use these incredibly detailed confidence logs to investigate incidents and really understand what the AI was thinking when something went wrong.
So when you put it all together, response confidence isn't just a number. As the source material puts it so perfectly, it's a required signal for monitoring, a direct control for your guardrails, and a crucial artifact for your auditors. It's a central pillar of any trustworthy AI program.
Which really leaves us with one final thought, one last question for you. For every single AI system your organization is using, whether you built it or you bought it, you need to be able to answer this question. Do you really know when your AI is confident and when it's just guessing? Because if you don't, then you don't really have a secure system at all.